Students, you are all aware that an oxoanion or oxyanion is a chemical compound with the generic formula AX(OY)Z negative. Now, let's recall some salts of transition metals containing oxoanions. These examples are potassium dichromate and potassium permanganate. Today, we will enhance our knowledge about the preparation and properties of potassium dichromate. Now, firstly, let us see what is potassium dichromate. Potassium dichromate, that is K2Cr2O7, is a common inorganic chemical substance. It occurs naturally as the rare mineral lopezite, that is K2Cr2O7. It is also found in the nitrate deposits of the Atacama Desert of Chile and in the Bushveld igneous complex of South Africa. Students, before going to study the preparation and properties of potassium dichromate, we will focus on oxidation states of chromium in its oxides. Oxidation states of chromium in its oxides. Chromium, having symbol Cr and atomic number 24, occurs in the oxidation states 0, +2, +3, +4, +5 and +6. In elementary state, chromium has 0 oxidation state and divalent chromium ion has +2 oxidation state. All states of chromium are unstable except +3 and +6. Chromium, having 0 oxidation state, produces a thin oxide layer immediately. Divalent chromium ion easily oxidizes to the trivalent form in air. The trivalent and hexavalent oxidation states of chromium are very important in chemical industries. The trivalent and hexavalent forms of chromium also form chromate and dichromate respectively, and a chromic anhydride form called chromium trioxide and chromic acid. In chemical industries, chromium trioxide is also known as chromic acid. The principal uses of chromium are in the metallurgical processing of ferrochromium and other metallurgical products to impart corrosion resistance, chiefly stainless steel. Now, let us see how potassium dichromate is prepared in a laboratory. There are various methods to prepare potassium dichromate. Here, we will discuss its preparation from chromite ore. It is also known as ferrochrome or chromium. Let's study various steps involved in its preparation.
Preparation of sodium chromate. Chromite ore is finely powdered and is heated with sodium carbonate in the presence of air in a reverberatory furnace. This reaction produces yellow-colored sodium chromate. In this reaction, ferric oxide and carbon dioxide are also formed. This reaction takes place in 2 steps. In the first step, chromite ore reacts with oxygen to form ferric oxide and chromium oxide. The chemical equation showing this reaction is named as equation 1. In the second step, sodium carbonate reacts with chromium oxide and oxygen to form sodium chromate and carbon dioxide gas is evolved. The chemical equation showing this reaction is named as equation 2. Now, multiplying equation 2 by 2 and adding the resultant in equation 1, we get.
Students, after this reaction, the solution is treated with water. So, sodium chromate is completely dissolved and ferric oxide is left behind. We can separate ferric oxide by filtration. Conversion of sodium chromate into sodium dichromate. The sodium chromate formed in the reaction which we discussed right now, is treated with concentrated sulfuric acid to form sodium dichromate. In this reaction, sodium sulfate and water are also formed. This chemical reaction can be shown by the chemical equation. Sodium chromate, concentrated sulfuric acid, sodium dichromate, sodium sulfate, water. Sodium sulfate on cooling separates as decahydrate, leaving sodium dichromate in the solution. Conversion of sodium dichromate into potassium dichromate. The sodium dichromate formed is treated with potassium chloride to form potassium dichromate. The reaction can be shown on screen. Now, after learning the various methods of preparation of potassium dichromate, let us learn about its properties. During the study of properties, we will deal with both physical and chemical properties. Firstly, let us concentrate on physical properties of potassium dichromate. It exists as orange crystals and is soluble only in hot water. Potassium dichromate exists as solid at room temperature. It dissolves in water to form ionic solution. Now, let us see the chemical properties of potassium dichromate. Here, we will see the action of heat, alkali and acid on potassium dichromate. Firstly, let us see the action of heat on potassium dichromate.
Action of heat. When potassium dichromate is heated on wire gauze, it changes to potassium chromate, chromium oxide and oxygen gas is also evolved during the reaction. The relevant chemical equation can be written as.
Now, let us see the action of alkali on potassium dichromate.
Action of alkalis. When sodium hydroxide is added to potassium dichromate solution, it changes to potassium chromate and water is also formed. Due to the formation of potassium chromate, color of the solution turns yellow. The chemical equation can be written as. Ionic form of the equation is also shown here. It depicts that dichromate ion reacts with hydroxyl ions to form chromate ion and water.
Do you know what happens when an acid like sulfuric acid is added into it? So let us see the result.
Students, let us now learn about action of sulfuric acid on potassium dichromate. When potassium chromate reacts with sulfuric acid, then potassium dichromate, potassium sulfate and water are formed as product. Also, color of the solution changes to orange-red. It is due to formation of dichromate ions. Ionic form of the equation is shown on the screen. It depicts that chromate ions react with hydrogen ions to form dichromate ions and water. This interconversion of chromate and dichromate and vice versa can be explained by the fact that in dichromate solution, the dichromate ions are invariably in equilibrium with chromate ion at pH equal to 4. So we get the chemical equation shown on the screen.
Now, let's see the action of another acid, say hydrochloric acid, on potassium dichromate.
Let us now learn about the action of hydrochloric acid. When potassium dichromate is heated with hydrochloric acid, a green colored solution is formed. The solution turns green on heating due to the formation of chromic acid.
So, when an alkali is added, the hydrogen ions are being used up. the pH of the solution also increases. As per law of chemical equilibrium, the reaction moves in forward direction. Finally, a yellow precipitate of chromate is formed. On the other hand, when an acid is added, the hydroxide ions are being used up. The pH of the solution decreases. As per the law of chemical equilibrium, the reaction moves in backward direction. Finally, an orange-red precipitate of dichromate is formed. Students, you must know that for the action of sulfuric acid on potassium dichromate, some conditions are required. These conditions are cooling and heating. Now, let us discuss these conditions one by one. When potassium dichromate is treated with sulfuric acid at room temperature, it forms chromium oxide, potassium hydrogen sulfate and water. When potassium dichromate is heated with sulfuric acid, it forms potassium sulfate, chromium sulfate, water and oxygen. Now, let us discuss the oxidizing property of potassium dichromate. Potassium dichromate also exhibits oxidizing property. Potassium dichromate reacts with sulfuric acid to form potassium sulfate, chromium sulfate, water and nascent oxygen is liberated as shown in the equation. Ionic equation is also shown here as it highlights that dichromate ions react with hydrogen ions and electrons to form tri-positive chromium ions and water. For the better understanding of the concept of oxidizing property of potassium dichromate, let us see how potassium dichromate oxidizes ferrous salts to ferric salts.
Potassium dichromate reacts with sulfuric acid to form potassium sulfate, chromium sulfate, water and nascent oxygen are formed. The chemical equation showing this reaction can be named as equation 1. Ferrous sulfate reacts with sulfuric acid and nascent oxygen to form ferric sulfate and water. The chemical equation showing this reaction can be named as equation 2. Now, multiplying equation 2 by 3 and naming this equation as 3, we get what is shown on the screen. Now, adding both equations 1 and 3, we get the final equation as the overall reaction can be written as these equations are used in estimation of ferrous ions in the volumetric analysis. Ionic equation is also shown on the screen.
Now, let us take one more example in which potassium dichromate also liberates iodine gas from potassium iodide. This reaction takes place in two steps.
In the first step, potassium dichromate reacts with sulfuric acid to form potassium sulfate, chromium sulfate, water and nascent oxygen. The chemical equation showing this reaction is named as equation 1. In the second step, potassium iodide reacts with sulfuric acid and nascent oxygen formed in step 1 to form potassium sulfate, iodine and water. The chemical equation showing this reaction is named as equation 2. Let us combine equations 1 and 2. We get the final equation as shown on the screen. We can also write the ionic equation as.
Now, we are going to take the help of chromyl chloride test for the study of chemical property of potassium dichromate.
Chromyl chloride test. Materials and apparatus required to perform this test are concentrated sulfuric acid, potassium dichromate, chloride salt, test tube, burner and dropper. First, chloride salt is taken in a test tube. Potassium dichromate is mixed with dichromate powder. Concentrated sulfuric acid is added into this mixture and the solution is heated. Vapors of chromyl chloride are observed. When these vapors are allowed to pass into sodium hydroxide solution, the solution turns white. On keeping for some time, the color changes to yellow. When potassium dichromate reacts with a chloride salt and concentrated sulfuric acid, reddish brown vapors of chromyl chloride are obtained. This reaction takes place in 3 steps as shown on the screen. K2Cr2O7 plus 2H2SO4 gives 2KHSO4 plus 2CrO3 plus water. KCl plus H2SO4 gives KHSO4 plus HCl whole equation multiplied by 4. 2CrO3 plus 4HCl gives 2CrO2Cl2 plus 2H2O. The overall reaction can be written as K2Cr2O7 plus 4KCl plus 6H2SO4 gives 2CrO2Cl2 plus 6KHSO4 plus 3H2O.
Children, now let us see what happens when potassium dichromate reacts with hydrogen peroxide. Acidified potassium dichromate reacts with hydrogen peroxide to form chromium peroxide. As a result, the color of the solution turns deep blue. Reaction of dichromate ion, hydrogen ion and hydrogen peroxide to form chromium peroxide and water is shown on the screen. After discussing the reaction of potassium dichromate with hydrogen peroxide, we will discuss the structure of chromium peroxide, that is CrO5, and oxidation state of chromium in chromium peroxide. Let us have a look at the structure of chromium peroxide. Here, chromium is surrounded by 5 oxygen atoms. Also, chromium has +6 oxidation state in it. Now, we will calculate oxidation number of oxygen in chromium peroxide, that is CrO5. As we know, 4 oxygen atoms are combined by peroxide linkage in chromium peroxide and 1 oxygen atom is normally attached. Hence, we can write it as oxidation number of chromium plus 4 into oxidation number of oxygen atoms combined by peroxide linkage plus 1 into oxygen atom normally attached is equal to 0. On placing oxidation number of chromium as X, oxidation number of oxygen atoms having peroxide linkage as -1 and oxidation number of oxygen atom normally attached as -2, we get X is equal to 6. So, we can say that oxidation number of chromium in chromium peroxide is 6. Now, we will enhance our knowledge about the structure of chromate ion and dichromate ion. For this, let us have a look at the structure of chromate and dichromate ion.
In chromate ion, one chromium atom is shown to be surrounded by 4 oxygen atoms and all the 4 chromium oxygen bonds are equivalent. In dichromate ion, 2 chromium atoms are shown to be surrounded by 4 oxygen atoms each. In dichromate ion, 2 tetrahedral are shown, sharing 1 oxygen atom at the corner. Bond length of chromium and oxygen and bond angle of CrOCr are also depicted. Children, here it is important to note that in both chromate and dichromate ions, chromium has D0 electronic configuration. This means that yellow color of chromate ion and orange color of dichromate ion are not due to the DD transition, but it is due to charge transfer. It also means that there is momentary transfer of charge from oxygen atom to metal atom, thereby changing di-negative oxygen ion to mononegative oxygen ion, and oxidation state of chromium reduces from +6 to +5.
After knowing the preparation and properties of potassium dichromate, let us have a look at its real-life applications. Application of potassium dichromate in real life. Let us first discuss use of potassium dichromate in cleaning. Potassium dichromate solution कई chemical applications ਵਿੱਚ oxidizing agent ਵਜੋਂ use ਹੁੰਦਾ ਹੈ ਅਤੇ ਲੈਬੋਰੇਟਰੀ ਵਿੱਚ organic compounds ਦੇ glassware ਨੂੰ ਵੀ clean ਕਰਨ ਲਈ use ਹੁੰਦਾ ਹੈ ਪਰ ਇਹ ਇਕੱਲੇ cleaning ਲਈ use ਨਹੀਂ ਹੋ ਸਕਦਾ ਬਲਕਿ concentrated sulfuric acid ਵਿੱਚ mix ਹੋ ਕੇ use ਹੁੰਦਾ ਹੈ ਜਦੋਂ potassium dichromate ਨੂੰ sulfuric acid ਨਾਲ mix ਕੀਤਾ ਜਾਂਦਾ ਹੈ ਤਾਂ chromic acid ਬਣਦਾ ਹੈ Children, let us now learn about determination of concentration of ethanol by back titration. Back titration is an analytical chemistry technique that allows the user to find the concentration of a reactant of unknown concentration by reacting it with an excess volume of another reactant of known concentration. The concentration of ethanol in a sample can be determined by back titration with acidified potassium dichromate. When the sample of ethyl alcohol is reacted with an excess of potassium dichromate, ethanol is oxidized to acetic acid. Students, ਕੀ ਤੁਸੀਂ ਜਾਣਦੇ ਹੋ ਕਿ potassium dichromate, which is usually acidified with sulfuric acid ਜਾਂ ਕੋਈ ਹੋਰ dichromate, ਨੂੰ ਇੱਕ solution ਵਿੱਚ back titration method ਰਾਹੀਂ amount of ethanol ਨੂੰ determine ਕਰਨ ਲਈ use ਕੀਤਾ ਜਾ ਸਕਦਾ ਹੈ ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਇੱਕ known appropriate excess amount of dichromate solution ਨੂੰ ethanol ਵਿੱਚ ਮਿਲਾਇਆ ਜਾਂਦਾ ਹੈ but it is kept in mind ਕਿ ਉਹ dichromate solution ਦੀ ਮਾਤਰਾ ਇੰਨੀ ਜ਼ਿਆਦਾ ਹੋਣੀ ਚਾਹੀਦੀ ਹੈ ਕਿ all the ethanol solution should react completely with it. A blank solution of dichromate having no ethanol in it is titrated using sodium thiosulfate with iodide ions, for example, potassium iodide in the solution. ਇਸ titration ਵਿੱਚ ਥੋੜਾ ਜਿਹਾ starch indicator ਦੇ ਤੌਰ ਤੇ use ਹੁੰਦਾ ਹੈ ਅਤੇ dichromate iodide ions ਨਾਲ react ਕਰਕੇ iodine ਬਣਾਉਂਦਾ ਹੈ ਜੋ ਕਿ ਅੱਗੇ thiosulfate ions ਨਾਲ react ਕਰਕੇ ਦੁਬਾਰਾ iodide ions form ਕਰਦੇ ਹਨ ਇਸੇ ਤਰ੍ਹਾਂ ਜਦੋਂ ਸਾਰੇ dichromate ਨੂੰ use ਕੀਤਾ ਜਾਵੇ ਤਾਂ thiosulfate iodine ਨੂੰ iodide ions ਵਿੱਚ convert ਕਰਦਾ ਹੈ ਅਤੇ the blue-black color from the starch will disappear, giving a clear endpoint. From here, calculations using balanced formulae easily yield the amount of ethanol in the original solution. Let us now learn about uses of potassium dichromate in leather industry. It is used in tanning of leather, which is used for footwear. Let us now discuss about use of potassium dichromate in photography. Potassium dichromate is used as an oxidizing agent together with a strong mineral acid in photography and in photographic screen printing. Let us now learn about use of potassium dichromate in silver testing. When it is dissolved in an approximately 35% nitric acid solution, it forms Schweitzer solution and is used to test the presence of various metals, especially for determination of silver purity. Pure silver will turn the solution bright red. Sterling silver will turn it dark red. Low-grade coin silver, that is 0.85, will turn brown. It is largely due to the presence of copper, which turns the solution brown, and even green for 0.5 silver. Do you know how potassium dichromate is used in wood treatment? Potassium dichromate is used as a finish on certain types of wood. It brings out the color and grain to a very deep, rich appearance. Let us now discuss use of potassium dichromate in homeopathy. It is used as a remedy in homeopathy by making medicines called Kali bichromicum or Kalium bichromicum. Safety. Potassium dichromate is one of the most common causes of chromium dermatitis. Chromium is likely to induce sensitization, leading to dermatitis, especially of the hand and forearms, जो कि chronic है ਅਤੇ ਜਿਸ ਦੀ treatment भी difficult है। ਇਹ toxic भी है with doses of approximately 100 mg per kilogram, being fatal in rabbits. As with other Cr6 compounds, potassium dichromate is carcinogenic in nature ਅਤੇ ਇਸ ਨੂੰ health ਅਤੇ safety protection ਲਈ gloves ਪਾ ਕੇ use ਕਰਨਾ ਚਾਹੀਦਾ ਹੈ। ਇਹ compound corrosive ਵੀ ਹੈ ਅਤੇ ਇਸ ਨਾਲ exposure ਨਾਲ severe eye damage or blindness ਹੋ ਸਕਦੀ ਹੈ। In this part of the episode, let's try to know with the help of some questions how much you have actually absorbed today. My first question is, what happens when potassium dichromate reacts with sodium hydroxide? The answer is, when sodium hydroxide is added to potassium dichromate solution, potassium chromate and water are formed. Due to the formation of potassium chromate, the color of the solution turns yellow. Next question is, what is the reason of color change when an acid like sulfuric acid is added to potassium dichromate solution? The answer is, the color change is due to formation of dichromate ions. Next question is, define back titration. The answer is, back titration is an analytical chemistry technique that allows the user to find the concentration of a reactant of unknown concentration by reacting it with an excess volume of another reactant of known concentration. Next question is, what is oxyanion or oxoanion? The answer is, an oxoanion or oxyanion is a chemical compound with the generic formula AXOY Z negative. Next question is, which acid is used to clean glass apparatus in the chemistry laboratory? Good. The answer is, potassium dichromate solution is used to clean glass apparatus in the chemistry laboratory. Next question is, what is the reason behind reddish-brown vapors obtained in chromyl chloride test? The answer is, when potassium dichromate reacts with a chloride salt and concentrated sulfuric acid, reddish-brown vapors of chromyl chloride are obtained. This reaction takes place in 3 steps as shown on screen. Next question is, what is the effect of pH on the solution of potassium dichromate or K2Cr2O7? C12O7? The answer is, in acidic medium, pH of the solution decreases and equilibrium shifts backwards. The color of the solution is orange-red due to the presence of dichromate ions. In basic medium, pH of the solution increases and equilibrium shifts forward. The color of the solution is yellow due to the presence of chromate ions. Well students, ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਅੱਜ ਤੁਸੀਂ potassium dichromate ਬਾਰੇ ਬਹੁਤ ਕੁਝ ਜਾਣ ਗਏ ਹੋ. Next time, we will again come back with a new topic. Till then, bye.